So here we are, straight line motion, part two, part dos, number two. Zle. When an object is subjected to gravity, which is pretty much all the time, if you're in physics, gravity's all around you, dependent on size and distance. Kind of interesting stuff. Its position function is given by this. Whoa, what the heck is that stuff? What is this VOSO? Well, VO is the initial velocity. SO is the initial position. In other words, the start. What did you start at for your velocity? What was it thrown at? What was it projected at? What was it falling at? What's happening there? And the initial position has the starting height or the starting position. Okay, now this one, notice here it says T is measured in sections. S of T is measured in feet for this one up here. Now I'm going to highlight the other stuff in blue. This other formula down here in blue is measured in meters. Key difference, negative 4.9 versus negative 16. And if you were to kind of measure those against each other, they'd be pretty proportional there as far as meters versus feet. So from our original, we can calculate the velocity function. So let's look at velocity in terms of feet here, because we're using the negative 16. Velocity is going to be negative 32t plus the initial velocity. And the acceleration is just going to be negative 32. Go figure. Gravity has a force or an acceleration that's equal to 32 feet per second squared. Okay, so that's general information here. That's just stuff we need to know in order to do the rest. This is background. Got to know this. Let's know some more. When an object is thrown upward or downward, in fact, it's still either way, it's subjected to gravity. We're usually interested in how high a particle reaches and how fast it's going when it impacts the ground or water or whatever it's doing. Okay, so when an object reaches its maximum height, it's going up, 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 velocity, positive, 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 and then when it's going to come down, it's going negative, 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 negative. So we have positive velocity going up, negative velocity coming down. What happens in the middle? We hit zero. At the maximum, right here. At the max, velocity equals zero. So how do we find this maximum height here? Well, it's kind of a two-step process. First, you set velocity equal to zero and solve for t. Figure out what is t. What is that time when it's equal to zero? Then you take that t and you plug it in to your position, because when is going to be a solution of time, and how high is going to be a solution of position. So first, you got to find the time, and then you got to plug it into S of t to find your position. Okay, now reverse order here. When an object hits ground, as in ground zero, ground level zero, that means that its height, or its position, S of t, equals zero. So to find the velocity of an object when it hits the ground, that means that we know the position was zero, then we're going to solve for t. Now we're trying to find the velocity at impact, which is going to be at the time when S of t equals zero. So that's kind of very similar idea, but reverse order. S of t equals zero, solve for t, find velocity. So it's a fact of just kind of knowing what you're trying to measure and how to calculate that. Let's start with an example and apply this real quick here. A projectile is launched vertically upward from ground level. Oh, big words there, ground level. That means that S of zero, in other words, the initial position, is equal to zero, because ground level means zero. And the initial velocity, in other words, v of 0 or v sub 0, however you want to say it, is equal to 112 feet per second. Units are important, but the number is even more important. So let's start out with some information here. Before I even find velocity in part A, to get velocity, I need position. So to get position, I would have s of t equals, we got the negative 16 t squared, plus the initial velocity, which is 112, times t, plus the initial position, which is 0. And that's just going to disappear anyways. So to look at velocity, that's the derivative of this first function, which would be negative 32t plus 112. All right. So t equals 3, t equals 5 are the moments in question, and it's asking me for velocity. So I'm really trying to find v of 3 and v of 5. So v of 3 is negative 32 times 3 plus 112, which I could simplify. But I don't need to, because we're just doing free response writing here. And if I want to find v of 5, that would be negative 32 times 5 plus 112. Now I'm going to find these two values here. I am going to simplify them, just to make some comparisons, because it's going to matter, not really matter, but help make B and C make a little more sense. So the first thing that I'm looking at is negative 32 times 3. That's negative 96 plus 112. That's going to be how much? So we add 4. That's going to be 16. Positive. It's important that it's positive. And velocity here, that's going to be negative 160 plus 112. That's negative 48. So here we're moving up at 3, and we're moving down at 5. Because remember that vertical movement, moving up or down, positive is up, negative is down. So something happens here in the middle. You go up, you come down, in the middle, you reach a maximum height. So part B here. Part B is saying how high. Well, that's two questions in one there. Because the first thing you got to figure out is what's t equal. And then after we figure that out, then we got to figure out what's s of t equal. Well, first of all, we know that v of t, our velocity at the height of this movement, is equal to 0 because it hits that stopping point. V of t equals 0. That's what we just noticed on the slide before, if you forgot already. But it's right here. Big star, we're going to use that a bunch. We're going to use the other big star for part C. But part B here, v of t equals 0. So that means that negative 32t plus 112 equals 0. So if I were to solve this, I move 112 to the other side, and then we got negative 32t, or that would be negative 112 and negative 32t. Divide both by negative 32. What do we get? I don't even want to mess with this. Let's just calculate it. So clear this. Clear. 112 divided by 32. I have a feeling it's something 0.5. 3.5. So t equals 3.5 seconds, of course. Now we're going to plug that in. And what's s of 3.5? That's really the height at which we reach a maximum. So that's equal to, okay, we got to plug this in, negative 16 times 3.5 squared plus 112 times 3.5. Okay, calculators. Negative 16 times 3.5 squared plus 112 times 3.5 equals 196. 196 feet, because we're talking about height. How high? The height. Okay, so that's part B, and that used the idea of, what did we do first? We had to find t, then we had to plug that in to find s of t, which is our height. Now let's look at part C. Find the speed of the projectile when it hits the ground. Okay, hits the ground, key phrase there. That means that s of t equals 0. And in fact, this happens twice, and we're going to see the kind of interesting piece there. Find the speed. Find the speed. So we want to know what is v of t when s of t equals 0. So the first thing I got to do, I got to find t. T equals, I don't know. So let's do s of t equals 0. That means that I have negative 16t squared plus 112t equals 0. What could we factor out? All right, does 16 go into this? Let's see, 16 would be 32, 32, 32. That's 96. And then we add another 16. So yeah, 4 times 16. This is going to be, if I factor out a negative 16t times t minus 4, that would give me equals 0. So my two options here, t equals 0 or t equals 4. Now something is interesting here. T equals 0 is in fact a solution to the algebra, but it's not a solution to the question. It's not really something that matters because this is the start. Of course, at the start, we started at ground level. That was told to us. But then we also finish at ground level at t equals 4, at time equals 4 seconds. So let's use that now. We're going to plug that in into our velocity. What's v of 4? Okay, well, v of 4, we plug into our velocity. We have negative 32 times 4 and plus 112. If we're to simplify this, we'd have, oh man, what are we going for here? Negative 32 times 4. Oh, plus 112. Oh, that's right. Yeah, we're right there. So velocity of 4, this is going to be negative 1, I can't even think right now. It's going to be 128. Something seems a little off here. Plus 112. So this is going to equal negative 48. Nah, that's not right. What are we missing? How many times does 16 go into 112? Oh, no, that doesn't go in here. That goes in 7 times. My goodness. I can't even calculate. So I got to do some erasing here. This isn't t minus 4. You guys are probably shouting at the screen, Mr. Butler. Come on, can't you factor? I can sometimes. So it's at t equals 7 seconds. So I'm going to plug in 7 into this 32, which is not going to be 128. It's going to be a lot bigger. In fact, I'll tell you exactly what it's going to be. It's going to be negative 224. Now, there's an interesting word here that I kind of ignored, but now I want to pay attention to it. It's speed. Remember that speed is the absolute value of velocity. So the absolute value of v of 4 is the absolute value of all this, which is the absolute value of this, which is the absolute value of negative 112, which is equal to 112. We're talking about feet per second. Now there's a little bit of reasoning going on in this, and calculus tests, especially AP Calculus, will often avoid this. But notice that it went up at 112 feet per second and it came down at 112 feet per second. That has a lot to do with kind of balanced forces and conservation of energy and such. So whatever speed it goes up at, it will return at the same point. Because we started at 0 and we finish at 0, that means our speeds are going to be the same as well. So that's just kind of interesting. But here's the calculations to back it up. So it's 112 feet per second at impact. It's pretty fast. 1 second. Boom, 100 feet. That was pretty fast. Okay, let's look at some other calculations that have to do with things falling and such. So let's read this information. The equations for free fall on the surfaces of Mars, Earth, and Jupiter. Now we're doing it in meters and t in seconds are, well, here's Mars. Notice that I'm given s of t in each of these. And I'm going to be asked probably something with velocity or acceleration. How long would it take a rock? Initially at rest. What does that mean? That means that the initial velocity, when you plug in 0, is at rest, or in other words, 0. And we're trying to figure out how long. That means t equals what when velocity, v of t, equals this number here that they're giving us, 16.6 meters per second. Let's start with the Mars here. We know that s of t is equal to 1.86 t squared. Then v of t is going to be the derivative of that, which equals, we drop the 2 down, we're going to get, what would this be, 372, 3.72 t. And I want to know, when does this, we want v of t to equal 16.6, and then find t equals something. So let's go ahead and set it equal to 16.6. 16.6 equals 3.72 t. So now it's just a simple algebra division problem. So we got our trusty calculators, just to speed things up here a little bit. 16.6 divided by 3.72. 4.4623. So t is approximately 4.4623 seconds. Earth and Jupiter are actually going to be the same. So just for time's sake, let's go ahead and work them out. I was just going to say, I'll let you guys do those ones, but I'll go ahead and do them. S of t is equal to 4.9 t squared. So that means v of t is going to be equal to 9.8 t. I'm trying to set that equal to 16.6 and figure out what t equals. So it's the same algebra, the same setup. 16.6 divided by 16.6 divided by 9.8. We got 1.6938. So 1.6938 seconds equals our time. That's how long it takes to speed up to 16.6 meters per second. Okay, this last one here, and by the way, 16.6, just arbitrary, nothing special about it. Okay, 16.6. We start out at Jupiter with s of t equals 11.44 t squared. And then when we do velocity, we're going to take the derivative, drop that to t to the first. So we drop the 2, it becomes 22.88 times t to the first. So when does that equal 16.6? That's actually going to be pretty fast. 22.88 t. Divide both sides by 22.88. 22.88. Let's see what we get. So 16.6 divided by 22.88 gives us 0.7255. So 0.7255 seconds equals the time. Done. Let's look at example 5. Wait a second. We are done with example 5s. Now, example 6. I don't know if you guys noticed, but there was 2 example 5s there. Kind of interesting. Not really. A rock is thrown vertically upward from the surface of the moon. Okay, we already know something. Surface of the moon from ground level. That means that s of 0 equals 0. And its velocity is 24 meters per second. So actually, they're giving us the measurement here. 24t minus 0.8 t squared meters in t seconds. So the first thing, A, find v of t and a of t. That's easy. That's called derivatives. V of t equals 24, the t to the first power, just goes to t to the 0 power, minus, drop the 2, we're going to get 1.6 t. A of t in this case is the derivative of that. The 24 goes to 0. And we're going to lose this t, and it's just going to become negative 1.6. Okay, so let's look at part B. How long? How long? That means we're talking about t equals something. Did it take the rock to reach its highest point? So its max, its highest point. What happens at its highest point? Well, it stops, only for an instant. In other words, its velocity is equal to 0. So let's use that information. Velocity equals 0. So that means 24 minus 1.6t equals 0. Hey, this has a t. I can solve for t and figure out what t equals. That means 24 equals 1.6t, or 240 equals 16t. How many times does that go in there? I want to say a lot. Let's see, if I divide both sides by 8, that gives me 3 equals 0.2t. Okay, and then divide by 0.2, or 30 equals 2. And that means that 15 equals t. So at 15 seconds, we're at the highest point. Okay, now we're talking about how high. That's a position question. So S of t equals what? At t equals 15. Okay, so S of t equals something at t equals 15. So S of t, which is our original equation, S of t is going to be equal to 24 times 15 minus 0.8 times 15 squared. Sounds like a calculator time for me. 24 times 15 minus 0.8 times 15 squared. 180. This equals 180. What are we measuring here? Meters. So this is 180 meters high. Excellent. How long did it take the rock to reach half its maximum height? So in other words, when was the position equal to half of 180? Which that's simple enough for us to simplify. When is it equal to 90? Okay, now we're talking calculator. Big time calculator stuff. So let's go to our function here, y equals. And what do you know? It's already set up. So what did I type in here? I'm looking at the original function, 24t minus 8.8t squared, and 90. I want to figure out when those two values coincide. And for a window, here's kind of my window. You can pause it if you need to, but I'm going to go from 0. Let's go from 0 to 20, just for fun. And this goes all the way up to 500. I think I only need to go up to like 200. Should be plenty. Let's look at the graph. So it looks like it hits 90 here. Then later on as well, but this first part, right about there, that's what I'm really interested in. So what is that point? Can I find that intersection? Yes, I can. If I go to second and calculate, I do click on 5 for the intersect. Now I just got to get close to that point. So I'm scrolling over. That looks pretty close. It's not second curve, still pretty close. Guess, still pretty close. It looks like my answer is 4.3933. So at t equals 4.3933 seconds, S of t equals 90. We're talking approximately here, but generally that's what's happening. Okay, so how long is the rock aloft? We have S of t equal to 0. T equals what? And not t equals 0. T equals question mark. How do I know this is what I'm asking? Well, because I start, I go up, and I come down. And what's happening at the start and the finish? S of t equals 0. So I'm trying to figure out, when is this? When is that finish point? When does t equal 0? Well, let's start with S of t, which was 24t minus 0.8t squared. So I can factor this. In fact, I can factor 0.8 from each one. S of t and a t. 0.8t. I'll make a negative come out as well. I don't even need to do that. Let's do 0.8t. That's going to be 3, no, not 3, 30 minus t. So what does t equal? T equals 0, of course, from the start, so we don't really care about that. And t equals 30 seconds. That is when I finish. That's how long it stays up in the air, aloft. All right, so at time equals 30 seconds, I'm done. I hit the ground. Done, hit ground. So what was the rock's speed when hitting that surface? Well, so in other words, what is v of t, absolute value because we're talking speed, at t equals 30? Okay, well, let's calculate that. That's going to be the absolute value of v of 30, which in this case is 24 minus 1.6 times 30, and then the absolute value of that. Let's calculate that. So if I clear this, clear, so we got 24 minus, that's not 24 minus, that's 24 minus 1.6 times 30. What do we get? Negative 24. So that's equal to the absolute value of negative 24, which is equal to 24 meters per second. Because we're talking about meters and talking about seconds. Okay, we got last little piece here. Is this the last piece? No, we got two more. All right, you know what? I'm going to stop the video here and kind of finish the last two. Hopefully, we can get to those. But I'm going to stop here. Maybe I'll finish the other two tomorrow, and maybe I'll extend the quiz. But we'll see. I'm going to stop these and go and upload these while I have a chance.